Today I'm breaking down one everyday headache, crowded intersections, and I'm stacking 4 engineering solutions side by side using a block-by-block logic map so you can see exactly where they differ and why. Fixed time signals, actuated signals, adaptive AI control. Roundabouts, block 1. Inputs. Fixed time, basically none. It runs a clock. Actuated, loop detectors or cameras that sense cars waiting. Adaptive AI, rich data, cameras, radar, connected cars, even bus priority feeds. Roundabout, human vision and right-of-way rules. People are the sensors. Block 2, objective function. Fixed time, maximize predictability. Trade-off is waste during off-peak. Actuated, minimize stop time per approach. Local to the intersection. Adaptive AI, network-wide delay reduction, emissions, priority lanes, multi-objective. Roundabout, minimize conflict points and delay via continuous flow. Block 3, control logic. Fixed time, preset cycle, and splits. If it's 60 seconds green, it's 60 seconds green. Actuated, extend green while demand persists. Gap out when it's clear. Adaptive AI, forecast arrivals and optimize phase plans every few seconds. It learns patterns. Roundabout, decentralized, drivers negotiate entry with yield control. Block 4, actuators, fixed time, red, yellow, green lamps and sometimes transit priority signals. Actuated, red, yellow, green lamps, and sometimes transit priority signals. Adaptive AI, red, yellow, green lamps, and sometimes transit priority signals. Roundabout, geometry, deflection, splitter islands, signage, no lamps in normal ops. Block 5, failure modes, fixed time, mismatch to demand spikes, queues explode. Actuated, bad detectors mean stuck reds or never-ending greens. Adaptive AI, data drop or bias can amplify unfair weights, needs fallbacks. Roundabout, poor design leads to confusion, low speeds and pedestrian risk if crossings aren't protected. Block 6, cost and complexity, fixed time, cheapest to deploy, costly to retime citywide. Actuated, moderate, sensors and maintenance add up. Adaptive AI, highest, sensing, compute, comms, and calibration. Roundabout, big upfront civil works, low ongoing ops. Block 7, scalability and resilience. Fixed time, scales easily, but performs poorly as variability de forces quays. Actuated, scales intersection by intersection, limited coordination. Adaptive AI, scales best across corridors, fragile without robust data. Roundabout, scales where space allows, shines in outages since it's passive. Block 8, humans and safety. Fixed time, predictable for drivers and pedestrians, can feel unfair. Actuated, fairer locally but opaque, people don't know why it changed. Adaptive AI, smooth when tuned. Transparency and equity audits matter. Roundabout, fewer severe crashes due to low speeds and fewer conflict points, needs good pedestrian design. When to pick which, stable, low-budget corridor, fixed time, variable demand at a few hotspots. Actuated, busy network with buses, events and sensors. Adaptive AI, space available, safety priority, power reliability issues. Roundabout, quick recap by logic. Less input equals simpler logic and lower cost, but less fairness and efficiency under variability. More input and smarter logic boost performance if you can afford the data, the tuning, and the maintenance. And sometimes the best controller isn't a controller at all, it's geometry. That's the map. Pick the blocks that match your constraints, not the hype.